Solving a great algebra question with flair. My solution and the smarter method by Martin Tutorials. I'm about to solve an algebra problem. Just a reminder, I have two YouTubes, Variety and Fun Math, which is all interesting topics and fun math, and Martin Tutorials Only Math. As today's question is more advanced math, it's only going to Martin Tutorials. I'm going to give away an advert now. This Professor Chris McMullen, I once ordered one of his books from online. I loved it so much, I kept getting more of his books. And I also got for a relative who's at first year university. I love his books because they are full solutions. Because it doesn't help if you get the answer as 8 and their solution is 11. And you just see answer is 11. That doesn't tell you where you went wrong or the correct way. Whereas everything is full solution, so you can check how it got there. And I find it relatively light. Like if you're going to study with a friend or in a library, you don't want to take a heavy textbook with. That's why I love these books. And also it's without any prejudice. It's one thing if this is a friend of mine or I want to support a friend. I've never met the man in my life. So this is without any bias recommending his books. And my policy is if I use a question from another book, I give the source. Well, I'm doing more than giving the source. I'm giving an advert. And the reason why this question interested me is because there's more than one solution. I solved it and I'm very happy with my solution. I found my solution impeccable, except his solution is even better than mine. So I'm going to show you the two methods, my way and what I call the smarter method, which is his method. Okay, we are given two equations, and of course this is exercise 12 in this book. X equals t plus u over 2 and y equals t minus u over 2. Also told x equals 0, y equals 0, y does not equal x, and y is not equal to minus x. Given these two equations I just mentioned, can we now transform the equation t squared minus u squared equals 4tz into this equation, 1 over x plus 1 over y equals 1 over z. Oh, one more thing, you'll notice my headings are very colorful. Besides the fact that color is nice, the real reason is I've run out of black inks. That's the other reason why they're colorful. Anyway, on to the question. Given these two equations, transform this equation to that equation. Okay, so here are the two equations we're given. That's meant to be a 2 despite my handwriting. What I did is I took each one of them and I multiplied by 2. So we've got 2x equals t plus u and 2y equals t minus u. And what I now did is I added the two equations and subtracted the two equations. And reminding you, I'm doing you my method and I'm going to show you his better method afterwards. If we add the two equations, 2x plus 2y equals 2t. And the 2's cancel out, we get x plus y equals t. And if we subtract the equations, we get 2x minus 2y on the left. And t minus t disappears. U minus minus u plus u. So we get 2x minus 2y equals 2u. And we divide through by 2, x minus y equals u. So now what I'm going to do, I'm going to take that original equation, which they gave us, t squared minus u squared equals 4tz, and to transform it to the other equation according to the question. What I do is I substitute in wherever I see a t, I put an x plus y, and where I see a u, I put an x minus y. So the t, we put in the x plus y. Instead of minus u squared, it's minus x minus y squared, because we said u equals x minus y. And the t here we replace with x plus y times z. Now we simplify, we open up this bracket. If we've got xy plus xy, which is 2xy, x squared, y squared. And when we subtract, I multiply this bracket with a minus sign. And 4 times x plus y plus z is like 3 terms being multiplied. It's like x plus y times 4z. My z smudged there. That's 4z times x and 4z times y. When we open up this bracket, the signs change. Plus becomes minus, minus becomes plus. And we just leave this as 4xz plus 4yz. And the next line I just left in pencil because I'm showing what I'm cancelling out. X squared minus x squared cancels out. and y squared minus y squared cancelled out. We're left with 2xy plus 2xz equals 4xz plus 4yz. 2xy plus 2xy equals 4xy equals 4xz plus 4yz. We divide everything through by 4. We get xy equals xz plus yz. And now we divide every term by xyz. Xy divided by xyz is 1 over z. Xz over xyz is 1 over y. Yz or z, depending where you live, divided by xyz is 1 over x. You'll notice I use cursive z. I don't do the regular z. That's just a personal choice because I might get confused with a number 2. And everyone's different. If you can do the regular z or z without having to transform like that, that's great. For me personally, it prevents confusion with a number 2. And given that it's what we're left with, 1 over z equals 1 over y plus 1 over x, we switch them to the other side of the equal sign. 1 over x plus 1 over y equals 1 over z. I beautifully transformed this equation, or I transformed that equation to this equation. I beg your pardon. I transformed the questions transformed this equation to that equation. I did that beautifully, and I did it by substituting into this equation, and it simplified to that one. That's the Martin method. I'm very happy with my method, except his method is even better than mine. So I'm going to the solution manual of his book, and it's question number 12. We were told, given x equals t plus u over given x equals t plus u over 2 and y equals t minus u over 2, what he did is he flipped it upside down. 1 over x equals 2 over t plus u. 1 over y equals 2 over t minus u. He added the two equations. If left equals right and left equals right, left plus left must equal right equals right. As I say, my age and my friend's age, if I say my age equals his age, my friend's age equals his friend's age, then my age plus my friend's age will equal his friend's age plus his age. Left equals left, left equals right, left equals right, left plus left equals right plus right. 1 over x plus 1 over y equals 2 over 2 plus u over 2 over 2 minus u. And now, in the next step, we kept the left exactly where how it was before. And what he does now, he adds the two equations on the right side by finding a common denominator. So here he multiplied this term by t minus u over t. He multiplied this term by t minus u over t minus u. He multiplied that term by t plus u over t plus u to give a common denominator. The left stays the same, the common denominator we add the tops. He multiplied out 2t minus 2u plus 2t plus 2u. The 2u's cancel out. 2t plus 2t equals 4t. And what he did was, we at the beginning of the question, we said show that t squared minus u squared equals 4tz. And of course in the denominator, the tu's cancel out. We've got t squared minus u squared. Well, it says show t squared minus u squared equals 4tz. That t squared minus u squared, he substituted in 4tz because they equal, because show from this equation, we're going to reach that equation. And we substitute that 4tz, and the t's cancel out, and the 4's cancel out. We're left with 1 over z, and we're therefore left with 1 over x plus 1 over y equals 1 over x. That's, we transformed, by substituting in there, we took this equation and substituting this term in, we went from this equation to that equation, and that's his method. I like both methods. I found his method is better than mine. And that's another question by Martin Tutorials.